Alright, so second video, we're now going to look again at a convex lens, but whereas with our previous one that we drew, okay, we had the focus there and we had the object further away from the lens than the focus. This time we're going to look at what happens when, instead of being further away than the focus, the object is closer than the focus. So I've still got convex lens, its focal length is still 6 centimeters. This time the distance of the object is only 4 centimeters, so it's actually inside of the focus. And for reasons that become obvious, I'm using a smaller object height this time of just 3 centimeters. Okay, so I've thought about what's going to happen. So I'm drawing my axis slightly differently to how I did it last time, but that's because I know what's going to happen. So there is my axis, and I'm going to put my lens here, nice and big again, arrowheads to show that it's a convex lens. And then just as before, first of all I'm going to mark on where the focus is on this side, and then mark on where the focus is on the other side. Okay, now comes my object. This time it's only 4 centimeters away from the lens, so that starts there, and it has a height of 3 centimeters. So carefully with the ruler, and again just a very simple arrow to represent my object. Okay, different color pen for the rays of light. Okay, I'm going to draw the same ray of light that I drew first last time. This is a ray of light that is coming in parallel to the axis of the lens. Okay, so as you remember, the rule there is that that ray of light comes out and it goes through the focus on this side of the lens. So that's my completed ray of light there. Okay, now the second ray of light that I would normally draw would be a ray of light that goes through the focus on this side, but that ray of light there isn't going to go through the lens at all, so we're not going to draw that one. We're only going to have 2 rays of light. So my second ray of light is the ray of light that goes through the center of the lens. Okay, so the rule there is that that ray of light does not get refracted at all, it just carries on in the same direction. So what we're seeing here is these 2 rays of light are actually diverging, they're spreading out. Those 2 rays of light on this side are never going to touch, they're never going to form an image. So what's actually happening is that we will get a virtual image, and the way that we find where that virtual image is we have to trace these rays of light backwards to find out where it looks like they're both coming from. So I'm doing this with dotted lines just to show that these aren't real rays of light. This is me just tracing their paths backwards. Okay, so we need to do this quite carefully to make sure that it's all good, and then let's trace those backwards, and we can see that those rays of light cross about there. Okay, so this time I have got the image on the same side as the object. Okay, and that is going to tell us that it is a virtual image. This is not an image that I can project onto a screen. This is an image I will see only when I look through the lens. Okay, and in fact this is how you would use a convex lens as a magnifying glass. Okay, very clearly the image is a much bigger size than the actual object itself, so that lens is working to magnify the object. Okay, so this is exactly what a magnifying glass does. Okay, so my image this time is not real, it is virtual. This time as well it's also upright, it's the same way up as my object. And what I can also do is measure, remember that was 3 centimeters. This is much bigger. I would say that is about 9.6 centimeters. Okay, so again I can calculate the magnification simply by doing the height of the image by the height of the object. Okay, and don't need a calculator for that one. That is a magnification of 3.2. Okay, so I've got virtual image, it is the right way up, and with a magnification of 3.2. Lovely, that's the end of that one.